Hello, welcome to Maths Live. I'm actually going to move this back a little bit. There we go. Hope you're all okay. We've got Darcy. Hi Darcy, welcome back. We've got Logan, hello. We've got Santino in Norfolk, hi. We've got Alex, welcome Alex. We've got Fatima and Zara in Pakistan, hi. We've got Tilly and Hannah. Welcome back, Hannah. We've got Ethan. Hello, Ethan. Right here. I'm going to put this down for a second. So your challenge question is following on from yesterday. So here's an angle. See if you can recognise which angle it is. It's been split up. And can you use your information about what type of angle this is to find out the measurement for angle A? Same here. You've got a certain type of angle with a certain type of size. And can you use that information to find the size of angle B? Give that a go. Ooh, lots more shout outs. We've got Sam. Hi, Sam. We've got Rufus and Ava. Hello. We've got Rowan. Hi. We've got Aaron and Xander. Hello. Got Sean, hello Sean. We've got some answers coming in for this, great guys. We've got Freya, Tobias, Sebastian and Barnabas. Wow, that's a busy household. Hi everybody, hello. Got Zach and Henry, hi. Got Liberty, hi Liberty. I'll put this down now. Okay. Oh, we've got Zach and Kent, hi Zach, hello. While you're finishing, I saw a couple of answers. I think some of you are still working on this. So I'm just put a title up. Because we're still calculating angles today. Oh. Okay, right. Let's have a look. So you should have spotted, hopefully, if you were here yesterday, you'll have spotted that this is a right angle. And a right angle is 90 degrees. So the whole of this angle adds up to 90 degrees. That means something plus 54 is 90. To find out the missing angle, you can either count up from 54 to get to 90, or you could do 90, take away 54. Oh, my pens, I wonder if they're going to last the rest of Maths Live. So, okay, I've got 6 there. 8 over 5 here. So if you got 36, then well done. Okay. And then with the next question, all of this, a straight line is 180 degrees. So that's the total. So 123 plus B is 180. So we need to do 180, take away 123. So that's 7, 5, 0. So B is 57 degrees. Let's see how we got on. 36 and 57. Well done. Brilliant. Oh, a few more I will come back to the shout outs in a little bit. Busy today. So well done if you got those. So how are we doing more calculating angles? Well, we're not repeating today's lesson, but we're still calculating angles. Because we're calculating angles in 2D. I'm going to fit that there. I like my titles to be clear. Angles in 2D shapes. You will need to know this in upper key stage 2 and going forward into key stage 3. So if you're a younger learner than that, amazing. Watch, learn, take it in. If you are in upper key stage 2, you might have seen this before. Obviously being not at school, you might not have, and it might be good revision for you. So what do we mean by angles and 2D shapes? So I'm going to think of some 2D shapes that you're really going to be looking at with angles. The most obvious one to start with is a square. Now, if we look at the vertices of a square, we know that the corner, the vertices of a square, is a right angle. Okay. And for the lessons this week, we have learned that a right angle is 90 degrees. So a square has 4 vertices, each of them being 90 degrees. So what we're looking at today is, what do all angles in certain 2D shapes add up to? So this plus this plus this plus this. So 4 times 9 is 36. So all angles inside squares add up to 360 degrees. Okay? And it's the same with a rectangle, because again, they are all the vertices of right angles. So 90, 180, 270, 360. So there's one fact to remember. All angles inside quadrilaterals, such as squares and rectangles, add up to 360. Does it apply to other quadrilaterals? Yes, it does. Okay. Okay. So quadrilaterals such as trapezium. This angle and this angle and this angle and this angle will add up to 360 degrees. You'll see this more in tomorrow's lesson. Parallelogram. Okay, I'm just going to draw. There's a reason why I'm doing this. So all 4 angles add up to 360 degrees, but also with a quadrilateral, such as parallelogram, these 2 angles are the same, and these 2 angles are the same. Don't worry, you don't have to take all this in. This is me just throwing some fun maths facts at you to do with angles and shapes. Okay? So quadrilaterals, they all add, it doesn't matter, even if it's an irregular quadrilateral, they all add up to 360. Okay, what happens if a shape isn't a quadrilateral? Now, I'm not going to be going into pentagons and hexagons and all that. I just want to stick to the main 2, which are quadrilaterals and triangles. Okay, and the rule is for triangles that they all, I wonder if you can guess. Do you remember when we were talking, if you've done Maths Live for a bit, and we were talking about how the area of a triangle is half the area of a rectangle? Kind of applies with angles. What's half of 360? It's half of 360, 180. So all angles in triangles add up to 180 degrees. And it doesn't matter what type of triangle it is. It could be an equilateral triangle. It could be an isosceles triangle. It could be a scalene triangle. Okay? Could be any of those triangles. They add up to 180 degrees. Now, with an equilateral triangle, they are all equal. All the sides are equal and all the angles are equal. So 3 times what is 180? What is each one going to be? What do you times by 3 to make 180? Well, what do you times by 3 to make 18? 3, 6, 9, 12, 15, 18. So each of these is 60. Okay? Because all the sides are the same length. Now, in an isosceles triangle, these 2 sides are the same length. So these 2 here will also be the same, and this one at the top will be different, okay? Because it depends how tall or fat, that's very mathematical language, it depends on the structure exactly of the isosceles triangle. Some can be really, really tall and thin, some can be a bit longer, okay? And with a scalene triangle, all the sides are different lengths. So all the angles are going to be different sizes. they will still add up to 180 degrees. So let's try a couple of examples. So I'm going to give you, let's try that isosceles triangle. Okay, so I'm going to write that it's isosceles. And if you get this question at school, they'll not tell you it's an isosceles triangle. It's like one of the things, you need to be able to spot it. Okay, so it might say that this angle here is, I don't know, let me think. Actually, you know what it might do? It might tell you this angle here is 35 degrees. I'm going to write that a bit bigger. So it might tell you this angle here is 35 degrees. What is the size of this angle at the top? You'll be thinking, how do I do that? How do I know what that one is when I don't know what that one is? Well, with an isosceles triangle, you do. Because as I mentioned earlier, all the two sides are the same length. The angles are also the same. So if that's 35 degrees, then this is 35 degrees. Right? Now, how do we find a missing angle inside a triangle? Well, we know that angles in a triangle add up to 180 degrees. So that means this angle and this angle and this angle adds up to 180 degrees. So what you've got to do first is work out the amount that you've got, first of all, for your angles. So you need to do 35 plus 35, which is 70. And then you work out, what do you add to 70 to make 180? Well, we know that's 110 degrees. Okay, so it's using those facts. Okay. Let me give you a go. I'm going to give you a turn. This time I'm going to do a scalene triangle. Okay, I'll draw a bit bigger than that. I don't like drawing scalene triangles. Because I'm always thinking I'm drawing a right angle, so you just got to believe me that it's not a right angle. So I'm going to tell you that this here is, let's say it's 85 degrees. And this angle here is 23 degrees. What is the size of this angle here? Give that a go using that knowledge. While I go back and do some shout outs. Oh, I've got to scroll back a long way. Okay, we've got Hector and Hans, welcome back. Hi Caris, hello. We've got Mia and Noah and Joe, hello. Got Frankie, hi Frankie. Got Avani in Birmingham, welcome. Okay. Got Arthur and Robbie, hi Robbie, hello. Looking. Harry and Rosie, hi, welcome. Okay. Oh yeah, brilliant. Yeah, we've got some good answers here. Oh wow, I'm struggling to keep up. You're all doing so well. Okay. What? Harry in Africa? Harry in Africa? Whereabouts in Africa are you, Harry? Please tell me. That's amazing. So we've got some people in Pakistan watching. We've got someone in Germany watching. We've got someone in Africa watching. That's amazing. Wow. Okay, so using our knowledge, 180 degrees. So these three angles have to add up to 180 degrees. So first of all, what we've got to do is add up the amount of that we've already got. So we find out how many degrees we already have. So that's 8. So these two angles here add up to 108 degrees. But we want 180. So then we have to do 180 subtract 108. Make that look like a 0. Okay. So 7. So that's 2. 7 take away 0 is 7. 0 take away 0 is 0. So this angle here is 72 degrees. Okay. Right. Going to give you another shake, guys. I'm not going to do as much sort of modelling and then give you 3 questions. It's going to be sort of to and fro and to and fro. And then tomorrow's lesson is going to be more complex problems. So I'm going to draw a shape. Okay. Right. I would like you to work out the size of this missing angle. Can you have a go at working out the size of that missing angle for me? Just looking. Brilliant. Oh, I got someone say they used to be in the Congo. In the Congo. Amazing. Right in the heart of Africa. It's amazing. Okay. Hopefully I've given you enough time there. So you might have spotted, hopefully, that it is a 1, 2, 3, 4-sided shape, which makes it a quadrilateral. So all the sides need to add up to 360 degrees. Right, there's our first fact. We've been given the size of one angle. So what are the sizes of the other 2 angles? Well, it doesn't have anything written there, but hopefully we'll have spotted, hopefully we should have spotted that there's a corner in each of them, so that means they're right angles. So these 2 are 90 and 90. So now to find the missing angle, we've got to add 90 and 90, which is 180. So those 2 there, 180. What's with me and my zeros today? They're like 6s. And then we add the 50. So 8, 13. So that's 200. So these 3 here make 230. We're not done yet though. That angle is not 230. We've now got to subtract the 230 from 360 to get our answer. Okay? And you know it's not 230 because that's bigger, that's a reflex angle, and this is an obtuse angle, so you know that can't be the right answer. So 0, 3, 1. So this angle here is 130 degrees. Okay, right, it's time for the 3 challenge questions. So let me get my hands on the 3 challenge questions. Okay, question 1 was, So in an isosceles triangle, name the angles. Name the angle types in an isosceles triangle. Number 2, all angles in a rectangle add to what? I know we've just done this. And number 3, oh, say I hate drawing scalene triangles. You should practice it. It's really hard drawing scalene triangles. Okay, so you've been given, I have to do this again. A scalene triangle. This angle here is 99 degrees, and this angle here is 44 degrees. What is the size of, come on pen, the missing angle? So what is the size of this missing angle? Let me know what you think. Ooh. Amazing. Well done, everyone. I'm just going back and having a look and reading through your messages. That's so good. Hi, Jamie. Hello. Okay. I'll give you 30 more seconds with that one. I don't want to jump in too fast. Hi, Eloise. Welcome. Okay, I'll get started. I'm just looking at the time. So, isosceles triangle. Now, it's not name the size of the angles, it's what types of angles are there. So if I just draw an isosceles triangle here. Okay. What do we think? Okay. Can you see that this is an acute angle? This is an acute angle. So they're all acute angles. All angles inside an isosceles triangle are acute. Okay. All angles in a what add up to. So we've already done this, haven't we? Rectangle. 90 plus 90 plus 90 adds up to 360. Okay, let me see if I've got some answers for the last one. Okay. Oh, got a few different answers. Let's see. Okay, so I rubbed it off the board, but all angles in a triangle add up to 180 degrees. So what we need to do is add the angles that we have been given. So we need to add 99 and 44. So 9 plus 4 is 13. 9 plus 4 is 13 again, plus the 1, that's 14. So 143 is the size of the angles we've got, but we need to subtract it from the total to know what's left, what this angle is. So that's 7, 3, 0. So it's 37 degrees. Well done if you got that. Okay. are your last 3 questions. So, question 1. There's your first question. Question 2. Is this. Getting pretty hard now. And have I got room to do the last one? I'll try. While you work away, I'm going to bend down here. Because this is one of my favourite questions. And this is tricky. Oh, rattle. Okay, so you've got 3 questions. Question 1, you've got a triangle. One angle is 60 degrees. What is another angle? Question 2, you've got a parallelogram. I've given you the size of just one of the angles. Can you work out what this angle is? And the last one's a real brain teaser. I've drawn a shape. I've given you the size of the 3 angles. Part 1 is where is the missing angle? Where is it? And can you work out the size of it? This is a hard one. It is hard. Oh, some people are giving that last one a good go. Oh, well done you lot giving it a good go. So I like it. It's supposed to be hard to be like, is it this? Is this? I like your descriptions of where it is. Where's my whiteboard rubber? So, hopefully for number 1, you spotted that it's an equilateral triangle. Where's my pen? There it is. It's an equilateral triangle, so therefore all angles are the same size. All angles in the triangle add up to 180, so it's 612, so that is 60 as well. They're all 60, they're all equal. If only one of the angles has been given, there's a reason for that. So saying that one is 60 means it must be an equilateral triangle. Okay? Don't know if you heard earlier, I sort of said it very quickly, that opposite angles in a parallelogram are equal. So that means these two are the same. And of course, it's a quadrilateral, so they all add up to 360 degrees. So if we know that these two are 100, if you subtract two lots of 100 from 360, you're left with 160. Okay? And then to find the size of one angle, so you know that these two are 200. Okay? So you have to subtract the 200 from 360. That leaves you with these two angles here, this one and this one, together makes 160. So those two there. 160, but we only want the size of one, this one. So you need to halve 160, which is 80 degrees. Hard question. Yes, hard question. Okay, but using that knowledge or practice this, even if you just see this once and go, huh, you'll see it at school, and I'll be like, ah. Right, I need some space for the last one. So I'm actually going to bend down to do this. I don't think I've ever gone down. I hope you can still see me in maths. I don't think I've ever done this in maths live. So where is the missing angle first of all? Right, let's have a look. It is a four-sided shape because there's 1, 2, 3, 4. And because it's a four-sided shape, all the angles add up to 360. So that's one important part. Okay. Now, I've given you 3 of the angles, but where is the other angle? Okay, so there's that one there where those 2 points meet. There's this one here where these 2 points meet. There's this one here where these 2 points meet. Ah, so it's where these 2 points meet, but it's this one here. So it's and you can see it's a reflex angle. So our size needs to be 100 more than 180 degrees, our answer. Okay, so what we're going to do is add the angles that we've been given. So 42 plus 12 plus 38, well that's 12, 4, 5, 6, 7, 8, 9. So those 3 angles together add up to 92. We know that all four angles must be 360 degrees. So if anyone's joining in Maths Live now, they're probably thinking, what is she doing? So 92, take up from 360, take away 92. To be fair, I'm really tall, and I think I am getting a bad back from doing Maths Live. So this is quite nice, standing up straight, sitting up straight. So we can't do this. So 8, okay? We can't do this. So it's 2. So 15, 14, 13, 12, 11, 10, 9, 8, 7, 6. 268. Didn't I say that the answer needs to be a reflex angle? And it very much is. That is definitely a reflex angle. Let's see what you all thought about that. Okay. Really close. Yeah. In between. Yeah, you know what? Some of you are like, okay. Yeah, I was close. Yep. A lot of you definitely identified where it was, so that's really, really good. Fantastic. And I like that some of you, while I was doing this, actually were like, oh, hang on, actually, and you were going ahead and working out, that's fine. Okay, so tomorrow I'm going to be back and we're going to be using all our knowledge of angles from this week to answer various questions. I'm very excited that yesterday I planned next week's Maths Live. It is the last Maths Live, given that a lot of you, not all of you, but a lot of you are going back to school the week after, and it's going to be a very, very special one. Some of you might have heard that on one day, me and Lara from Theatre of Science and Holly from English with Holly are all going to be doing, we're going to be doing a mashup on World Book Day. And tomorrow I'm going to be releasing all my week's schedule to do with Maths Live. But let me just give you the hint to you, you're the first people I'm going to tell, that even though it's going to be Maths Live next week, it might not necessarily be themed around maths, given it's a very special week. Anyway, try the challenge question after this, and I'll see you tomorrow to finish angles.